So example one says Peter Pan is walking back and forth along a straight road. Peter has walked 15 meters before he starts recording data for his speed as shown in the table. Part A, use a left Riemann sum. Oh yeah, remember those? To estimate the integral from 0 to 6 of v of t dt. Give the meaning of this integral. Here we go. All right. When we are finding Riemann sums, we are finding area of rectangles. So the area of the first rectangle, the width, it goes from 0 to 2, so the width is 2. What is my height? Why is it 24 and not negative 15? It's a left Riemann sum. We do. That's why I said several times at the beginning of class to get your calculator. The next rectangle, it goes from 2 to 3. Therefore, the width is 1. And the height is negative 15. The last one, it goes from 3 to 6. So I have 3 times negative 5. That's my Riemann sum. Leave it there. Okay, but the second part says give the meaning of this integral. And as you will remember, if you were listening to me during the notes yesterday, we need 3 things when we're explaining the meaning. It is the noun, the units, and the time. So Peter's, what is this? What is the integral from 0 to 6 of, hold on. We talked about 3 things yesterday. We talked about displacement. We talked about total distance. We talked about position. So which one is this? This is the displacement. Peter's displacement. And what are the units for displacement? No, meters. In meters. From t equals 0 to t equals 6 seconds. Okay. Part B. Give the meaning of this expression. 1 over 6 times the integral from 0 to 6 of the absolute value of v of t. It is not.
The average.
That is a noble try.
Average.
The answer to give the meaning, he says total distance.
It's a 6.
Oh, okay, hold on. What is that 1 over 6 times the integral? It's
Average.
it's an average value. 1 over b minus a times the integral. It's an average value of what?
So listen. That's right.
I already said that was not correct in this case, but apparently that didn't sink in. It's the absolute value of the velocity, which is, let's just throw out a math term and hope it sticks to the wall. What?
Speed.
Oh, it's speed. I get it now.
Average speed.
Isn't speed always positive? Is it not right here?
Speed is always positive
Why isn't it? So
because of the 1 over 6. Okay.
That wasn't there. You told us.
Correct. Okay, but since we're finding the average value, all right, that changes it. So it's the average speed of Peter. And what are my units? Meters per second. From t is equal to 0 to t is equal to 6 seconds. Okay. I'm positive actually that I will not have to remind you about the fundamental theorem of calculus part 2, because that's kind of important. It says if little f is continuous on an interval from A to B, and we have big F, which is an antiderivative of little f, then I can write this. I've got the integral from A to B of little f of x dx. That is equal to, what is the antiderivative of little f? How do you know? It says so. All right. So I anti-differentiate, and then if I have bounds, I plug in the bounds. Okay, so I'm going to plug in b, subtract, plugging in a. Okay, so I have big F of B minus big F of A. Okay, so I'm going to use the fundamental theorem on this next example. It says, suppose you are given the function f, whose graph is shown to the right. It is also known that g of x is the antiderivative of f, and g of 6 is equal to 4. Okay, so a couple of things. This g of 6 is equal to 4. That is, well, let me ask you, what is that in terms of what we did yesterday? Okay, I think we're on the right track there. We learned yesterday, in order to find position, it is what plus what? It's the initial value plus the displacement. So what is this? This is an initial value. I can also say g of x, it's the antiderivative of f. So I'm going to write this antiderivative f of x dx. And I can also write in my lower bound. Aha, what is my lower bound?
0.
There are lots of them out there. 6. Okay. This right here tells me the lower bound, because the initial value is associated with 6.
Okay, I have a question. How do you know that, like, that's the initial value? Like, why can't that just be like a random formula?
Okay, in some sense it is, okay? But what they're telling you, if they give you this random point on a line, right, we have to start there, because that is the only point that they give us.
Okay.
So how else could you, for example, in this next problem, part A, this is a position problem, g of 0. Okay, so I need to write an expression for g of 0, and it's a position problem, so I need an initial value and a displacement. What's the only initial value that I have? It's 4. Okay, so I have 4 plus the integral from 6 to 0 of f of x dx. Okay, so now, how do I get the integral from 6 to 0? Well, I don't have an equation, so I've got to use the graph of f and find the area under the curve. All right, and I'm going to start it here at 6, because that is the point that they give me. Okay, so look. I've got a triangle here that has a base of 2 and a height of 2. So my area is 2. And then I've got another smaller triangle that has a base of 1 and a height of -1. It's below the x-axis. So this has a net area of -1/2, since it's below the x-axis. Here I have a rectangle that's below the x-axis. So the area is -3. Okay. The other thing is I am integrating from 6 to 0. It's moving backwards, right to left. Therefore, I've got to change the sign. Okay, so G of 0. Well, let me just solve this. Okay, so I've got 4 plus, okay, from 6 to 4, it's 2, and so I'm changing the sign, and so that's going to give me -2. And then I've got -3.5 from 4 to 0, and I change the sign there, so it'll be plus 3.5. And so that's going to give me 2 plus 3.5. So G of 0 is equal to 5.5. How about you do the second one there, G of 10? Do that for me, please, right now. Why don't you confer with your friendly calculus neighbor there for a second? Make sure that we,
Let's go. Sure.
I swear to God.
It's okay. We'll finish this one.
Jacob, I do not want to fit in with you at all.
all right, so look up here. And we have 4 plus 4 equals 8, but
Oh, no.
I'm waiting for somebody to say new house.
It is fucking pizza.
It's not what I was waiting. I'm waiting for somebody to say new house, you don't get any credits. Why not?
Oh,
There's no integral.
I put the integral.
So hold on, wait a second.
Bald is bad.
All this bad. I'm not going to watch you erase. I'm going to conveniently turn my back to you. And I'm going to erase this. I'm not going to see who was being a lazy calculus student, who was not. I'm going to write 4 plus the integral from 6 to 10 of f of x dx. Now we're in business. So I've got my initial value, it's a position, plus the value of the integral. I'm going from 6 to 10. It's a triangle with a base of 4 and a height of 2. So my area is 4. I do not need to switch it because I am going from left to right. All right.
All right.
That gives me 4 plus 4, which is equal to 8. Okay,
Let's go.
questions over anything? All right, well, example 3. The velocity of an object is given by v of t is equal to 7 sine of 3x squared at time equals 3 seconds. The object is at 5 meters. Again, this is what? Initial value. All right, and so I'm pretty sure at some point they're going to ask me a position question. Aha, it's right there. Where is the object at? At t is equal to 8 seconds. Okay, so I need initial value plus the displacement. What is my initial value again? It's 5 plus the integral. My lower bound is going to be the time at the initial value, which is 3. My upper bound is going to be what they asked me, 8. And then I need to write in v of t dt. Then you can take your little calculadoras, do a little math 9,
So
and crank out the action, the answer. Yes.
what would you circle for the answer? Because I'm confused when you said like put the integral there.
No, the answer is 8. Okay, but what I'm saying, if you just write down 8 and do not have an integral there, you will not get full credit.
Okay.
You've got to have an integral.
Okay. it goes.
So you've got to have 4 plus the integral from 6 to 10 of f of x dx.
Does it matter 9 or at 8?
Math 8 is the derivative. Math 9 is the integral. Which you should be able to figure out if you hit one of those 2 buttons. All right, check your answer.
3 1.
Calculator's too slow.
Don't I do? I go alpha or something?
5 points.
Alpha. Alpha what? Trace.
Oh, he's doing the final.
On the edge. X graph.
Okay. So you should get 5.029 or 5.03 meters. Okay, so
To put something to the power of dx.
No.
What?
Like he's asking you to put dx to a power.
Good job.
are you math 9?
Rachel, what did I do wrong? I got the 1029.
Check that. Okay, so look up here, guys. Look up here for a second. If it were me, I would probably go ahead and include the initial value in the expression when I'm typing it into the calculator so that I get a final answer. All right, and I don't make any careless mistakes in leaving that off. Okay. So part B is what is the total distance traveled by the object from t is equal to 0 to t is equal to 2. So total distance is going to be the integral. My bounds this time are 0 to 2. And since I'm finding total distance, I need absolute value of the velocity. So put that into your calculator. Crank out the answer.
Oh. How do you do the?
Why is it so slow? Oh, yeah.
Math, ABS. It's slow because it's doing a Riemann sum of 10,000 rectangles.
I know, but it seems just really slow. Like it takes like a solid 5 seconds.
How long will it take you to do the sum of 10,000 rectangles? A little longer.
Quicker than that.
Oh, easy. Random number.
Just keep getting anything that may be broken.
All right, take half a second to get mentally prepared for the FRQ.
I'm still loading, so.
And let's go. Here we go.
I'm still waiting.
2016, question 2. Calculator allowed. So here we go. For t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t is equal to 1 plus 2 sine of t squared over 2, and the particle is at position x equals 2 at time t is equal to 4. So as I read this, I probably make a mental note, say, since they give me an initial value, at some point they're going to ask me about a position. But after I read it, the very first thing I do is what? Put the equation into your calculator. Make sure that it is right. Make sure you are in radians. Put the equation into your calculator, and then we're going to fly through these questions like a hot knife through butter.
Okay, I'm ready.
No, we just solved it. They got crazy. I put it in, it's second. Yeah, just put it up into the hole.
All right,
Dude, what?
here we go. Everybody ready?
Yes.
Part A. At time t is equal to 4, is the particle speeding up or slowing down? You, of course, remember when Newhouse brought, who was it? Was it Joe? I can't remember. When I brought somebody up to the front of the room and I pushed them all the way to the door and then I pushed them all the way back to the desk because that person was the velocity and I was the acceleration. Therefore, if the velocity and the acceleration have the same sign in either direction, then the particle speeding up. If they have opposite signs, then the particle slowing down. So I need to find V of 4. And I need to find V prime of 4, which is also the acceleration at 4.
It's just.
Well, that's what we're about to do. But you need to transfer that information from your calculator to the page. So, all right, so look here. I have my equation. How do I get V of 4? How about the table? Second graph. My table says that V of 4 is equal to 2.9787. So write that down. How do I get A of 4? The acceleration is the derivative, math 8. All right, so math 8, it's with respect to X. I'm going to use my little shortcut here. Alpha F4 gives me Y1. And I'm evaluating at X is equal to 4. And so my acceleration is negative 1.164. Write that down. So since my velocity at 4 is positive, my acceleration at 4 is negative, the particle is slowing down.
Wait.
How do you find the acceleration?
Yeah, how do you get the acceleration? I thought you were just.
Okay. How do you get the acceleration from the velocity? It's the what? It's the derivative.
Oh, this is the velocity graph?
Yes.
Oh, okay, good.
And how do you know it's the velocity graph?
Because it says big T.
Exactly. Okay. So to get the acceleration, I need to find the derivative, and I'm going to use my calculator, math 8, to take the derivative of the velocity at 4.
Wait, oh, never mind, I'm stupid. I thought we were trying to position.
All right. Let me go back. Let's write this down. So V of 4 was 2.9787. A of 4 was negative 1.164. And I'm going to say the particle
Is speeding up.
is slowing down because the velocity at t is equal to 4. Is positive and the acceleration at t equals 4 is negative.
There's one question.
That's part of it. Part B. Part B says find all times t in the interval for t between 0 and 3. So we're not including endpoints. When the particle changes direction, justify your answer. Okay, so let's justify it first. How do we find when it changes direction? The velocity must be 0 and there's got to be a sign change. Okay, so I'm going to write that down. The particle changes direction when V of t equals 0. And changes signs. So now I need to find when that happens. So I'm going to take my little calculator. So look at this for a second. I'm going to graph the equation, but first you need to change your window settings. Okay, so what are the bounds? It goes from 0 to 3. So look, go to your window, put in 0 to 3. Otherwise, when you grab it, you're gonna have a whole bunch of times where it crosses the x-axis, but we don't need those. All right, we just need this. All right, so here's the graph on the interval from 0 to 3, and I see that it crosses the x-axis, okay? So since this is a velocity graph, it's going to be equal wherever it touches the x-axis, and it crosses it right here, so I need to find this point. So trace that, find the 0. Is everybody okay with doing that?
I found it.
Take your little spider, do the left bound, right bound guess. All right. And you should get 2.707. So I'm going to say this occurs when t equals 2.707, since b of t changes from positive part C. Read me part C, please.
Find the position of the particle
I knew they were going to ask me about position because they gave me an initial value. So position is initial value plus displacement. What is my initial value? And please be careful, don't make a careless mistake. It is 2 plus the integral. All right, what's my lower bound? Where is it defined?
4.
At 4. And I want to find the position at t is equal to 0. So 0 is my upper bound. And this is going to be v of t dt. And I also notice that my bounds are out of order. So I can rewrite it and make it negative if I switch the bounds. 0 to 4, v of t dt. So put 2 minus the integral from 0 to 4 and plug in the equation there and crank out the answer. And you should get negative 3.815. Part D says find the total distance the particle travels from time t is equal to 0 to t is equal to 3. So total distance is going to be the integral. My bounds are 0 to 3 this time. Since it's total distance, I've got to take the absolute value of v of t dt. So put that into your little calculator. Crank it out.
That's problem, baby.
Now, should get 5.301. And since we blew through these questions with time to spare, I probably have like 10 minutes to sit back, relax, maybe eat some Orate candy that Newhouse gave me right before the AP exam to help me out before the second wave of FRQs, non-calculator comes. All right.
Go. I- yeah, it's only gonna